AOPS number theory 2.7. How many prime numbers are multiples of 3? So the definition of a prime number is that it's only divisible by 1 and itself. So if a number, for example 6, is a multiple of 3, then it's not only divisible by 1 and itself. So same with every other multiple of 3, it's not only divisible by 1 and itself. So the only prime number that's a multiple of 3 is 3 itself. So that's the only prime number. So there is one prime number that's a multiple of 3. Number theory 2.8. How many prime numbers are multiples of 10? So a prime number is a number that's only divisible by 1 and itself. So if we do like the first few multiples of 10, so 10, 20, 30, 40, well, obviously 20, 30, and 40 wouldn't work because they're multiples of 10, so it's not only divisible by 1 in itself. So then if we test 10, 10 is also divisible by 2 and 5. So it's not only divisible by 1 in itself. So there are 0 prime numbers that are multiples of 10. 2.9. Determine which of the following natural numbers are prime and which are composite. So A is 313. So if we square root 313, it's 313 is in between 17 squared and 18 squared. So we only have to check all the prime numbers up to 17. So if we list all the prime numbers up to 17 and see if it's divisible by 313, it's not. So this number is prime. And B, 343, no, 343 is in between 18 squared and 19 squared. So we only have to test all the prime numbers up to 18. Well, since 18 isn't a prime number, 17. And if we test it, since 343 is equal to 7 to the power of 3, that means it's not a prime number. So that means it's composite. C, 391. 391 is in between 19 squared and 20 squared. So we test all the prime numbers up to 19. And if we do that, we will find out that 391 is equal to 17 times 23. So 391 isn't prime, so it's composite. D, 427. So 427 is in between 20 squared and 21 squared. So we test all the prime numbers up to 20. So it's up to 19 because 20 is not prime. And since 427 is equal to 6 times 61, that means it's not prime, so it's composite. E, 569. 23 squared is in between 569 and 569 is in between 23 squared and 24 squared. So we test all the prime numbers up to 23, and there's nothing that's under 23 that's a prime number. That's a divisor of 569, so it's prime. And F 853, so 853 is in between 29 squared and 30 squared. So we only have to test all the prime numbers up to 29, and if we do that, there are no prime numbers that are divisors of 853 under 29. So 853 is prime.